First off, I want to acknowledge the land acknowledgement. We respectfully acknowledge the University of Arizona is on the land and territories of indigenous peoples. Today, Arizona is home to 22 federally recognized tribes, with Tucson being the home to the Oodam and Yaqui. Committed to diversity and inclusion, the university strives to build sustainable relationships with sovereign Native nations and indigenous communities through education offerings, partnerships, and community service. Cooperative Extension actually has offices on five Indian tribal lands in Arizona, though we work with all 22. And we even here in Maricopa, we work with many of the tribal folks in Maricopa County as well. So I think we can all agree that water in Arizona is really an important issue, an important topic. It's used by a great number of people for many different things. I'm going to talk to you today about using it for agriculture, but truly it is probably our most precious resource that we have here in Arizona. Currently, our water supply for Arizona comes from four major areas. 30%, 36% comes from the Colorado River, 18% are from in-state rivers, 5% is reclaimed water, and 41% is groundwater. So depending on where you live at, it depends on what type of water that you use. Many of you may or may not know the Colorado River,
Oh.
the CAPP. Oh, sorry.
Switch.
The CAP canal it's about a $3.2 million canal that was put in by the federal government and basically brings water from the Colorado River all the way down to Tucson. Now, when we signed up for that in Arizona, in order to have the federal government fund the CAP, what Arizona did is give up some of its rights to Colorado River. And when I say give up its rights, it actually went lower down in the list of priorities. So that when there were cuts, and there have been cuts now that we've experienced in the Colorado River, agriculture would be the first to take the cut in Arizona. The 41% groundwater, you know how that works, right? We basically drill a hole down, right? Drill in a well. We have aquifers that are underneath that we pull from. Some of them have high salt content, some do not, depends on where you're at. Some of them are perched water tables. The Maricopa Ag Center itself has several wells that are on it. I don't know if they're still operating Old Salty. That was the name of the well, because it had salt water in it. It was very high in salt water. You know that basically it gets recharged from rainfall. So we even have recharge sites where they were bringing in CAP water, and if you had more than you could use, you'd send it to the recharge site and you just recharge the groundwater with that. So I started back in '92. So in '92, I came from the state of Michigan. Michigan gets about, I want to say 34 inches of rain per year or so. Arizona gets 7 on a good day. I moved from Michigan, and my first year here in '92, I started July 1st. That winter was the first time I ever packed sandbags for flooding. We actually had flooding. We had so much rain back in '92. All the reservoirs were filled. There was water running down the Salt River. Maricopa Farm, about 320 acres, got totally flooded out. I couldn't believe that I came to this place and there's just all this water, and now here we are 32 years later, and we're down to almost nothing in our reservoirs. The Colorado River, 36%. You know that it's getting lower and lower. I know it's getting lower and lower because my wife likes to go to Vegas, and I like to drive, and so we drive over the Hoover Dam, and I've seen that water get lower and lower and lower as the years go on. This is the CAP canal that brings the water down through the central part of Arizona. Our in-state rivers, or the Salt River, still has some water flowing, though not continuing all the way through Phoenix. This is kind of what I normally see. I personally live in Ahwatukee here, so that was another thing coming from Michigan. I saw these signs for rivers. but there was never any water in any of them, and so I always wondered why. Uh, there's also the Gila River, which flows out in the east part, and San Pedro River, and then also the Verde River system and the Blue River. So we have some in-state rivers that help feed agriculture and that we rely on for agriculture throughout the state. Reclaimed water is only about 5%, and that's basically that purple pipe that you see. We don't have a whole lot of it that we're using for agriculture per se. There is a little bit here and there that's being used. There's some reclaimed water being used in, I think I want to say the San Carlos district, but I can't be 100% sure. Most of our golf courses and all are on reclaimed water, so they use reclaimed water. The town of Maricopa actually has a whole separate system, which is kind of neat, and so they use reclaimed water on all of their landscape, where now in Tukey, where I live, it's drinking water that we're using on landscape. And then the current water use, 22% is being used by municipalities. Industry is using about 6%, and 72% is used by agriculture. So agriculture certainly is the number one use of water. So if you're going to have an impact on saving water, conserving water, yes, we can work with the local municipalities. We can put in low flow toilets. We can put in low flow uh, faucets and things like that. But truly, it's in agriculture and irrigation where we can have a very big impact. Agricultural water use, the major crops is Farm Bureau. I think, I talked this morning, or we talked this morning when we were having lunch, or breakfast rather, about all the crops we can grow in Arizona, right? So there's crops that we can basically grow 12 months out of the year. Coming from Michigan, we were always planting in May and then harvesting in August, September. Here we're planting in September, harvesting throughout the year. Actually, that May is when we stop planting because things are getting so hot. So, we have lettuce and we have dairy, we've got pecans, we've got lemons, we've got citrus, all different types of things. So this is one thing. I am an engineer by training, so there are going to be equations and charts that we're going to use, and there will be a test at the end, so please pay attention. 10 gallons for every acre that you irrigate. That's a rule of thumb. So you need a pump, you need a water source for at least 10 acres, or 10 gallons per minute per acre that you have. So if you have a 20 gallon per minute pump, you could probably irrigate about 20 acres. You can do with a little bit less, but not too much less than that. If you're running off of city water, city water is usually about 50 gallons a minute, 40 gallons a minute. And so you could do a good size, there's no doubt about it. 10 gallons per minute per acre makes sure that you're getting enough water onto all your crops and you're not irrigating 24 hours a day. So how many people here are currently irrigating? And so, do you know what size?
We're transitioning properties from like an acre and a half now. We'll be at 5 acres in a few years.
And do you know the flow rate of?
I don't know the flow rate on our. We're on city water.
You're on city water.
Yeah.
But we're on city water.
City water as well. So folks always ask me how do I tell? And you can put a flow meter if you want, right, and just come up whatever your pipe size is, or you can do the old-fashioned way and get a 5-gallon bucket, right, and fill that bucket up. I know it's real old-fashioned. I'm smiling back there, and time it, right. And if it takes 15 seconds to fill up 5 gallons, and you just multiply that by 4, and that means you have 5, 10, 15, 20 gallons per minute that's coming out. And so you could do something as simple as that. So you can figure out, whenever anyone asks me, I want to start a farm, I've got some land, I'm thinking of putting in whatever, it doesn't matter what the crop is, the first question I ask is, do you have water? Oh yeah, I've got water. And you got a well? Yes, I have a well. Does it work? Yes, it works. How many gallons per minute does it put out? I don't know. That's the number one thing you have to find out. find out, and that will tell you how many acres that you can irrigate. The higher, the more, the higher your flow, the less time you're gonna have to spend irrigating. So basically, if if I had 10 gallons per minute and I had 15 acres, you'd be irrigating just about all day long in order to keep up with crop water use. This is really simple, but it's something that we have to remember. Remember, water is moving through a pipe, or that if it runs uphill, it's losing pressure. All right? So as water goes uphill or it goes through a pipe, you're actually losing pressure. There's friction that's being caused as it's moving through the pipe. So that's the second thing I ask. What's your flow rate? What's your pressure? Probably don't know what your pressure is either. Once again, most city pressure is going to be about, I don't know, maybe 40 psi or so. Once again, you can put a pressure gauge on to find out.
We do have a well, and we definitely find that when we use the well, the pressure is so low.
So low, yeah. So, I mean, one of the things that you can do is farm downhill, because you build up pressure as you go, or you have to get a bigger pipe, right? So pressure is really important as far as making sure you can get water out to the furthest reaches of your farm, wherever it may be. Like I say, when it runs downhill, there's a pressure gain. You need to kind of keep that in mind as well. I worked on a system, and it was actually it was up in Tuba City at the Hubble Trading Post. Everyone's been up there. It's really cool. And on the Navajo Nation, they put in a new underground system coming out of the lake up there, and they were irrigating alfalfa, I think, at the time. And they got ready to open the system up, and they had alfalfa valves, and they must have had a 16-inch pipe going down the side. And they turned that thing on, and it was all downhill, and it just blew the bottom of the pipe to pieces. There's so much pressure that was coming out because the lake was uphill, they were downhill, and the pressure coming off of it was just enormous. There are things you can use, things you can put in to reduce your pressure. That's usually not a problem for small acreage. If you have too much pressure, usually the problem is you don't have enough pressure. Remember also, when the water goes through a churn, goes through a valve, you lose pressure. So one of the things I always tell folks, if you're working on a system, and you're working off city water, and you find out that it's 40 psi, you're putting in a drip system, the drip system only needs 15 psi. Well, if you put 40 psi in, most of your drip systems are going to start blowing apart. They'll start popping out. Things will start popping off left and right on you, and you won't get the right flow rate, so you have to knock it down. So the last thing you put on your system is the pressure reducer. Put the valves on, all the other things. The last thing that goes on your system before it goes to the field is the pressure reducer. But if you reduce the pressure before it, drop it down to 15, then it goes through a valve, and then it goes through a filter. Coming out of the valve, coming out of the filter, you started at 15, you're already down to 12. Now it has to go out to the field, so you have to do it the other way around. So this is something that's important. Once again, an engineer like myself. This is a chart, and I know it's kind of hard for you all to see, but we're looking at gallons per minute right here, 1, 2, 3, 4, 5, up to 10. And this is the size of PVC 40 pipe. And this is the flow rates, velocity in feet per second, and PSI loss. I don't know that you really care what the flow rates are and what have you. What you do care about is the shaded area. So what you want to do is you want to make sure you stay out of the shaded area. So on a 1/2-inch pipe, it's saying that you can put about 4 gallons per minute through a 1/2-inch pipe without any worry. You can put 5 gallons per minute through and you'd probably be okay. But if you start getting into 10 gallons per minute at all, you're really putting a lot of water through that pipe. You're losing a lot of pressure, a lot of friction happening, and you're causing a lot of problems for your irrigation system. If you move up to 1-inch pipe, the most you can put through is about 12 gallons per minute in 1-inch pipe. I've got a system in my backyard right now. It's 1-inch pipe, and I'm probably putting about 15 gallons per minute, and I certainly know that I'm putting too much through it, and I'll tell you why in a second. The problem is that you're going to get what's called a water hammer. And that is when you shut off the system, it's moving at such a high velocity that actually it makes the entire system shake. And so I know that because when my irrigation system comes on, I can hear the pipe in the walls go boom. And when it turns off, I hear the boom again, and it's making that pipe shake because it's just too much water moving through too small of a pipe. And you'll actually cause damage to your system. And you'll start blowing holes through your system left and right as that water hammer occurs. So this is stuff you can find on the internet easily. But you really need to take care not to try and put too much water through small pipe. People think that if I get a smaller pipe, I'll improve my pressure because the water squirts out further. That's just the opposite. As you make the pipe smaller, you're actually decreasing the pressure because you're losing more and more. If you want to increase flow, you need actually bigger pipe. So there's water use. This is something that you need to find out. We don't have a whole lot of data, I can tell you right now. Because there's not a whole lot of support for doing research to find out how much water a crop uses. This is some information. Here we're looking at broccoli. Peak water use is about 0.2 inches per day. Total is about, there it is about 20. So it'll use about 20 inches in a season if you're going to grow broccoli. But the one that you really want to look at is that peak use. You want to be able to deliver at least 0.2 inches in a single day. So whatever system you're putting out there, whatever system you're working on, you've got to figure that you're going to use at least 0.2 inches per day. If you irrigate every day, obviously you need to be putting on that much. If you're irrigating every 5 days, that's an inch of water.
I got a question.
Yeah, go ahead.
Is that cubic inches or are we talking minus inches?
That's just inches. So it's not cubic inches or minor inches. That's how many inches of water, an inch of water, an acre inch, if you want to call it that. So it's not inches of that. The cubic inches and the minor inches are flow rates. And this is not a flow rate. This is an actual amount of water. So volumetrically. So if I had an acre of broccoli, I would have to put 20 inches of water over a season on that acre of broccoli in order to bring it to full maturity. So that's what we use. Now, as far as the flow rate is concerned, that's dependent on your system, right? And so that's a gallons per minute question. So does the variety that you grow affect water use? Marcus says yeah. So the variety of lettuce that you grow, so if you're growing romaine lettuce and you're growing a different variety of romaine lettuce, does that use the same amount of water or is it different?
The biomass. The biomass is produced.
Right. For the most part, I mean, the variety, what you're growing definitely makes a difference. But the variety, if it's a honeydew, if it's a sunnydew, if it's whatever dew, honeydew melons use about the same amount of water no matter what variety they are. There are some varieties, there are some plants out there that are drought tolerant. Drought tolerant doesn't mean that they use less water necessarily. Drought tolerant means that they'll tolerate drought. They'll stay alive. They will maybe grow smaller. They can take it. They can take the heat a little bit better. But it doesn't mean that they'll use less water. I give the example of a saguaro. If you've seen a saguaro out there, saguaros are very drought tolerant. But you can go around at least, I want to say maybe 2 weeks ago in Alatuki, we had a storm come through, and you can go around the neighborhood and you can tell who's been over irrigating the saguaro because all the saguaros are underground. Because the saguaro will use an awful lot of water when it can, if there's water there. But it is drought tolerant. It can actually live without water for a long time. So there are drought tolerant crops. But as far as the variety, whether you're growing one type of lemon or a different kind of lemon, lemons are lemons. So for the most part, it's going to be about the same amount of water. Does nutrient management count? Well, certainly if the plant's sick, it uses less water. If it's nitrogen deficient, it'll use less water. And so I've had people talk to me. I had someone call me and say that their tree, they had a citrus tree, and they've been putting water on it, and it seems to be running off. It looks sickly. The leaves are looking sickly. Put more water on it, Ed, and it's getting worse. I don't know what to do. I can't. Well, what they were doing was they were putting so much water on, they were actually washing the nutrients out of the soil, and so it was actually a nitrogen problem. So I had their leaves analyzed, and they were having a nitrogen problem. The last thing they wanted to do was put more water on it. It had nothing to do with water. It was actually a sick plant, and that's why it was actually using less water, and that's why it was puddling up and getting even worse. Does this irrigation system matter? So does the irrigation system matter for what the plant will use? Not what you apply, but what the plant will use. And the answer is no. So the system does not, the plant doesn't care how it gets the water. You can flood irrigate, you can drip irrigate, you can sprinkler irrigate. The amount that you put on will differ for sure, but what the plant will take up will be the same. Corn uses about 24 inches of water. If you flood corn, it'll use 24 inches of water. If you put on 40 inches, it'll use 24 inches of water. If you drip irrigate, it will use 24 inches of water. That's what it will use. So the system itself does not dictate what the plant uses. The system will dictate how much water you actually apply. And that's because of efficiencies, right? So if you've got a drip irrigation system and you're putting the water right where the plant is, and you're not irrigating in between the rows, and you're not over irrigating, those systems are like 95% efficient. And so the amount of water you put on, if it was 20 inches, you're putting on pretty close to 20 inches, maybe 21. Sprinkler systems, even small sprinkler systems, same thing. Flood irrigation, now you're getting closer to 70% of efficiency. So that means that you've got to put on quite a bit more water in order to get the same amount done. So if we look at it, this is our efficiencies. Surface and flood, usually about 60 to 80% seasonally, but peak use about 70 to 85%. Surface irrigation, flood irrigation works well in just about it works very well with our soils here in Arizona, first off. It's very cheap. It's already there for most of the systems that you're being on. But we lose a lot of efficiency early in the season. We just put in a new sprinkler, Zinke, I think was his name. He's out by South America Copa. He's part of our water conservation program. And he had a flood irrigation system. He was growing corn for his dairy. He put in a sprinkler irrigation system. The plants are about this big, and when he surface irrigates, he puts on 4 inches of water. Now, it doesn't matter what time of year, when he puts on his water, he puts 4 inches on in order to get the water to the end of the field. And so he'll put 4 inches on. And a plant that's that big needs about a half an inch. And so that's where he loses off in efficiency. I was talking to him, and he saved, putting that in, he saved close to 2 acre-feet of water because he had to over irrigate, right? He had no choice. With a sprinkler system, he can put a half an inch of water, he can speed that thing up, he had center pivot, he turned it on road speed, it went around really fast, it applied a half inch of water, that's what the plants needed, and that was fine. If he would have surface irrigated it, he would have put 4 inches on. Level basin, that's another type of surface irrigation. It's a little bit higher. That's where you kind of level everything up and fill it up like a bathtub, and then it goes in. Sprinkler irrigation. Oh, you can't see it on that. Oh, we lose it. Yeah, I never thought of that. That's right. Sprinkler irrigation, 75 to 85. That's even getting higher now. Some of your sprinklers, especially drop nozzles and stuff, little micro sprinklers, you're getting really high in efficiencies on that. And then drip irrigation systems, I put 85 to 95. Just realize that you can take any drip irrigation system and mismanage it. You can get down to 80% efficiency. I mean, it's very easy to do. I know I have that in my backyard. Once again, for me, it wasn't that I was down to 85% efficiency. It's that with the sprinkler or with the drip irrigation system I had, it was totally buried. And one month I got my water bill from the city of Phoenix, and it was off the chart. And I'm like, something's not right. And so I don't have a flow meter in my backyard, but I started going around and checking it. And so I ran the system and I started walking around, and sure enough, I found there was a break in the system, but it was buried. And I never saw it, and the water was just going straight down, never really puddled or anything like that. And so, my garden was more than happy. I mean, I was still getting enough water. I was just wasting water. And so that's a kind of a challenge with drip irrigation systems as well. So what do these mean in a practical sense? So in a practical sense, if we look at the broccoli, if it's 100% efficient, you're putting on 0.2. If you're 90%, you got to put on 0.22, 0.25, 0.29. So it's not a whole lot of difference. At least you're not thinking that. Going across, you're talking about 0.2 to 0.3, but over a season, that will add up very quickly. So as you're putting on different types of systems, if you're doing a surface system with 70% efficiency, you've got to put on about a third as much water to make sure that everything sees at least 0.2 inches. Right? That's your goal. You don't want to under irrigate anything, so you end up over irrigating and you end up putting on too much water. Irrigator's equation. You can Google it. It is a wonderful thing. And they're going to have copies of these on them, presentations. So yeah, you'll get copies of this. QT equals DA. I've done it, I've changed it over so that it's in gallons per minute. Most of the time when we're doing this in agriculture, we're looking at cubic feet per second. We can do it in minus inches and divide it by 40, but QT equals DA. Q is flow, T is time in hours, D is depth, and A is area. So if you know 3 of these things, you can determine the other one. I told you I'm an engineer, and there'll be questions. This is such an easy equation to use, and it works. I don't care if you're on a drip, if you're on the surface, if you're on sprinklers, this will work. If you know what your flow rate, and you find out what your flow rate is coming off of your well, and you know what your area is that you're irrigating, and you know what depth you want to put in, plug that in, and it will tell you how long you have to irrigate for. Or if you know your flow rate, you know your area, and you know you irrigated for 2 hours, it will tell you how much water you put on. It's very, very easy, very straightforward. 50 by 50 foot sprinkler system delivering 20 gallons per minute. How long does it take for me to put on 0.5 inches? Half an inch of water. QT equals DA. Q is 20. Time is, or depth is 0.5. 50 times 50 is 2,500. Just keep going down. So about 0.66 is about 40 minutes. So if I have a 20 gallon per minute flow rate, and I want to irrigate an area of 50 by 50, and I want to put a half an inch on, I should run that for 40 minutes. What I think you'll find, and what I have found many times in many cases, people are under irrigating. And so that's, you really using this as a guide. And if you're out there and you're irrigating and you normally irrigate for 45 minutes, yeah, that's pretty good. This is a guide. If you're irrigating for an hour and a half, you're probably putting on way too much water. If you're irrigating for 20 minutes, you're probably putting on too little water. One of the things that I tell folks that they can do, and I don't have one with me, and I wish I did, they're called a penetrometer. And that's what they're called, but actually it's just a piece of steel rod. That's all it is. You can pay an extra, $20 and call it what you want. But if you get a piece of smooth rebar, it works. And it works really good in our soil. After you irrigate, wait an hour or so, let the water drain naturally, and then push this into the soil. And as you're pushing into the soil, you'll notice it's going in pretty easy, and then it will get hard to push in. That's how deep your irrigation goes. That's how deep that irrigation went down into the soil. Do it a few times, then take the average. Sometimes you'll run into a rock, and you got to take another spot. But if you want, that is a great way to find out. I've got my citrus tree in my backyard. I do a little flood irrigation on my citrus. I've got it hooked up to my hose, and I've got a buried line there, and I fill up the basin back there. And what I did when I first started is I basically turned it on for a half hour and waited, and I went out there, and I know for a tree my size, I'm looking to get down to about 3 feet or so. Anything after 3 feet, probably wasted water. Even though the tree probably has roots there, 90% of them are going to be in the top 3 feet. For your crops, depending on what they are, most vegetable crops, 90% of your roots are going to be in the top foot. So if you're growing lettuce, if you're growing watermelons, if you're growing tomatoes, you're looking at about 18 inches max, so a foot and a half, 2 feet at the most. If you push it down and it goes 4 feet into the ground, you over irrigated by a whole lot. You need to cut that back. Or once again, you go out there and you find out that it's only going 6 inches down. It will look wet to you. The plant will still grow. It just won't grow as much. And then by the time you finally get to the end of the season and then you're starting to harvest, you notice that you're not getting as much as you thought you would. The reason why is because you're not irrigating enough. Like I said, most of our problems we run into is not over irrigating, but not irrigating enough. So, drip irrigation systems are low flow. They don't require a whole lot. Most systems run on maybe 15 gallons a minute, some even less than that, depending on the size. As you get to larger acreage, you got to look differently. Remember too, if you're putting in a drip system, that the water, wherever it's entering your field, has to get all the way to the end of the other side of your field. And as it goes through, it's going to lose pressure. So I had someone who put in, and I want to say, what size are those plots at Maricopa, drip plots? What's the length of those? Is that 400 or 200?
Yes, less than 270.
270?
370.
370? So 370 feet. And what happened is we put in a system. It ran on 15, it was a drip system. It was supposed to run on 15 gallons per minute. And it was a pressure of, I don't know, maybe 15 psi. And so, I mean, at the beginning of the system, I had more than enough. But I noticed at the very end, the plants looked smaller. It just looked kind of smaller to me. They looked fine. I mean, they looked happy. They just looked smaller. And when I went to the very end of my system and checked it out, I was down to about 10 psi back there. I had lost 5 psi going through the system, going through this, going through that. And you got every time it took a turn, the water took its turn, it loses pressure. So you've got your manifold, and every time it goes off into another drip tape, you're losing pressure. And I lost too much pressure by the end, so I had to up the pressure at the beginning in order to have the right amount of pressure at the end. Installation costs are coming down on drip systems. They really don't cost a whole lot to put in. They do require intensive management. So when you're flood irrigating something, you're putting 4 inches on. If you put on 3.5, it's going to put on a half inch less water. Not going to kill the crop one way or the other. With a drip system, you miss a day or two and you could lose a crop. There's not a whole lot of storage, and you can't catch up on many systems. So you've got to take care and watch that system very closely. If you use a buried drip system, if you bury your irrigation system in drip tape, you've got to watch it really closely like I did. You could have holes out there that you never knew about. We also found out, and depending on where you live, a lot of critters love to chew on drip tape. They're not looking for water. We actually put out bowls of water, cans of water, so that they want water. There it is. They just like to chew on it. That's period. So we had to do it, and most of them are pocket gophers, right? And they're out there, and that's what they're doing. They're chewing up your tape. And if you've got an acre or two, can't see it, especially if your crop is pretty high. So what I always tell folks to do, no matter what system you use, put a pressure gauge and put a flow meter on it, and figure out what your system's supposed to have. So if you've got a system and you're putting it on an acre and you're supposed to be putting out, I don't know, 20 gallons per minute, let's say, and you look at your flow meter and it's 20 gallons per minute and the PSI is 15 PSI, everything's running good, and then you go out one day and you notice your flow meter and you're running 30 gallons a minute. And chances are there's a hole out there somewhere. Or if the pressure drops down, chances are there's a hole somewhere in that system. Conversely, if the pressure goes up and the flow rate goes down, you're getting clogging out there. So something is clogging up your system. So you've got to watch it. You've got to also have pretty clean water for most drip systems. Most of them have very small tubing. They'll plug very easily. No matter what you can do, you can't unplug it once it's plugged. You can prevent it from plugging if you want. With the hard water that we have a lot of calcium in our water. So if you put an acid through your system, it will help a little bit in keeping those emitters open. But once it's plugged up, trust me, I've tried it. You can stick a needle, you can try and clear it out. You can put it in lime away. Once it's plugged, it's plugged. And you just need to replace. But they are highly efficient. And you're looking at 95% efficiency. What you put on is what the plant takes. Sprinkler systems, usually those are medium flow, though they're getting to some that are even low flow at this time. Installation costs, once again, are kind of coming down. It depends on what you've got and the type of system you're looking at. Most of us, when we're looking at small acreage, we're not thinking of putting on a center pivot or anything, but you still might be looking at putting in sprinklers. They do still have intensive management. You got to watch them. You've got to think about what you're growing when you're using sprinklers. If you're growing crops that are sensitive to having water sit in them, such as lettuce, that's a problem because what will happen is the water will collect inside the head of lettuce. You know, that romaine lettuce, and then disease can occur there. Or you might actually get, if you have really hard water, you get actually salt stains and what have you on that lettuce, and so you have to be careful. But the water usually doesn't have to be as clean, so you can get more stuff through it.
Does the height of the sprinkler affect how efficient it is?
It does to an extent because of the wind. So the closer you are to the ground, the less susceptible it is to drift in the wind. So that's why usually we have a lot of drop nozzles. You'll see them out there, and it's very close. So that usually helps reduce the amount that you lose in drift.
Is that pretty significant?
It's significant to a point. The old systems, the sprinklers were at the very top of the system. They lost quite a bit. Here in Arizona, it's significant in that you get a windy day, or you have a day like today or tomorrow where it's 114. The water actually evaporates before it even hits the ground. So it's definitely an issue.
Question going back a couple slides on using that irrigation equation. Do you adjust it all for like planting density or space within that area?
No,
not really.
Not really. I mean, the only thing that you might want to adjust for is if you've got a drip system and you feel like you're only irrigating the bed and you're not irrigating in between, you might reduce the acreage.
And just only count the bed.
Only count the bed, but not the pathways, yeah. And that's where you can save a little bit of that. Everything else, though, you're irrigating the whole thing. Yeah.
I have a question about the drip too.
Like I know clogged lines, like there's all the answers I've gotten have been like, well, inject acid, but a lot of our systems aren't set up to
Inject.
Put the injectors in. So looking ahead, if someone's just starting out, maybe they could just put that little section in the manifold to be able to put the acid in there.
Mm-hmm.
Is there anything else besides replacing entire lines and systems? And I'm thinking more like the quarter-inch.
Yeah. The little tubes that were coming out.
Yeah.
There really isn't.
I'm like hoping someone can give me a good answer, but.
Once again, it's acid, so salt and vinegar, you don't necessarily need to get sulfuric acid and do it, especially if it's smaller, but once it gets clogged up, there's nothing that I know of that will do a good job of unclogging.
And then in Arizona, using like city water, what's the average lifespan of those quarter-inch lines, you think?
Actually, depending on how often you irrigate, they'll last a long time. They really will. The quarter, especially the quarter, is the half-inch line that you use, and that's the one that is really susceptible to the sunlight, and it will start splitting on you. But the quarter-inch lasts a fairly good time. Sometimes you'll get, it's the emitter at the end, and that will be the thing that will cause you problems. So there's a couple ways you can do it. You can either put the emitter on at the base and then have the tube come off the emitter. And then if the emitter gets clogged, you gotta basically, replace the whole thing. I always do it so that I have the tube first and the emitters at the end. And 9 out of 10 times the clog is the emitter. It's not the quarter inch. If you've got the quarter inch that's getting clogged up, you have some really crappy water that you're working with. And you might not be irrigating very often, and that's usually a problem of it, right? And I don't know if you've got, perhaps there's algae or something building in. I'm not sure, but for the most part, I mean, I've seen drip tape out there and drip systems out there, 10 years plus. They've replaced the emitters, but the system itself has lasted longer.
So if you do frequent irrigation, that's better to save against clogging with it?
Yeah, it is because you're keeping everything dissolved. Once it starts to dry up, then it starts to accumulate, and so you're pushing things through as you're irrigating more often. So it's just and then of course, when you're doing surface irrigation like this, a lot of times we're not talking in GPM, we're talking cubic feet per second. Almost no pressure. Almost all of our systems are gravity fed, no matter what they are. Management's not as intense. Installation's pretty cheap. Water quality really isn't a problem. I've seen fish come through irrigation systems. But the efficiency is really poor, right? You start to run into that problem where you have poor efficiency. And so if you don't have a whole lot of water to use, this is definitely not going to be the way you want to go. I don't know how much more. Oh yes, and don't forget efficiency. So looking at that one problem we were looking at, we said it takes about 40 minutes or so to get on a half an inch. But 40 minutes of irrigation time, whatever the crop may be, if you're doing a surface system, you're talking closer to 60 minutes. And that's where efficiency comes in. And that's where you'll start to run into issues depending on the system that you have. And so that's something that you constantly got to kind of deal with.
Say someone's interested in, if like it makes sense for their operation to switch from flood to sprinkler or a drip system. Are there resources or funding available for that type of position? For me,
Go ahead, Carly. Yeah, go ahead.
Yeah, NRCS is available in NRCS to do cost share for that kind of thing. Cost share? Is it matching or is it?
It's a 75%, but unless you're underserved, then it's 95% reimbursement.
There's also a water conservation program with the University of Arizona. I'm not sure what they have left, but there isn't. Closed for this year, but they're going to open up another.
For some period of time. So now you can apply right now, but it might open.
It might open again. Yeah, I think that we've got another $9 million to spend, but we didn't get to spend it this year. So the bunker, he's our soil health specialist, and he's been working with the program pretty closely. But that was another opportunity too that you could, and that it's not, there's no cost sharing or anything. It's strange with the growers that we have been working with. We basically will pay them $1,500 an acre to switch over to a more efficient system. So they're working on flood, and they can either switch to a more efficient drip system or a more efficient sprinkler system. It's up to them, and they get to pick who they're going to work with as far as the vendors and all of that. Up to this point, we've put in pretty close to, is it $30 million or so? Is it more? It's 45 plus 60, about 60 million that we've put in, I think, plus or minus.
Yeah.
And of that, of the 60, they put in, the growers have put in an additional, I want to say $40 million of their own money.
Yeah.
So what they did is they took that money that we were giving them, the state actually, was providing the funding, and they were adding to it so that they could have even a better system. And what it does is it keeps water behind the dam, right? That's the whole purpose of that program, is to keep water back there. Yes.
Is there a limit on the scale of farming?
What? No, not on a scale. But there's an upper limit of $1 million.
1 million, total $1 million.
You can't get more than $1 million for your farm.
But for like a scale farming, like
No.
1 acre or 100,000?
No, it doesn't matter.
Works.
What you have to do is you have to show that the system you're going to put in will save water.
20% more efficiency. That's it.
So if you if you had a system and you were surface irrigating, you've got some records that you've been putting on, 24 inches a year, and now you're going to put in a drip system and you're going to be putting on 16 inches or 19, whatever. That's all it needed, and they would help you pay for that. And then up to $1,500 an acre. So it didn't matter which size. That wasn't the problem. Mostly is per money per grower or per company, and then of course growers and companies and stuff, they get, you got the limited and you got the brothers and so it's families, and I don't really own that. And anyway, we don't have to worry about that.
Do they have to provide like results, like a report?
So they don't necessarily provide results, but we work with them to provide results. So we have folks that go around, check, make sure the system's put in, and then get data from them to show that they.
I think do they have a clause for 3 years?
Yeah.
That we will be working
with them.
Yeah, something is they have like a flow meter, they come and check how much you get something.
Not only flow meter, I mean, our specialists go.
Yeah,
We have technicians go.
Right up that.
Yeah. So we took that.
Distribution and everything.
No, it's not an annual grant. It was a one-time funding from the state legislature. And so, and then they funded it again, in a different way. So the first year when we got the 40 million, it was a grant, and then the second year was just part of our funding for the cooperative extension. So we have folks that are going out, and we told people, some people are going to claim that they saved that much, and they might not. So we're not gonna take the money back.
Yes.
But if you had a flood system and you put in a drip and you didn't save as much water as you thought, that's fine. We'll find out using this grant. We'll find out the information so we can actually better estimate. And so looking at future investments in cooperation with the growers. So that's how that program is working. And so the bunker's on the team that decides which growers get their money and which don't.
Well, it's not competitive. It's just we just scrutinize the application. Sorry.
Have you denied
Yeah,
applications?
Because it's like a Google form or something.
Right.
So you fill up an online form and very basic information, but you have to like put all this information.
Yeah.
So if someone masks any information, then we go back and ask questions, and then if they cannot answer, we have irrigation specialists there too. I'm the soil specialist.
Right.
There are irrigation people sitting in that board, so
Yeah.
they can tell you if you can do it or not.
Right. Most of the challenge we have with growers is they're not used to number one fallout forms. But also some of them don't want us coming back and we're going to get this data from you, and they don't want to share that data. And so we said, well, then this isn't the program for you, right? And you're not supposed to be using this. You're supposed to take that acreage and reduce it. You're not supposed to be using this water on the other acreage, and we're supposed to be saving water behind the dam. That was the whole purpose of this. It cost us, the state of Arizona, about $230 per acre foot to save for this program. If you were to use a desalinization kind do that, I think it's upwards of $600 an acre foot or something. So we're actually getting a good deal out of it. Plus, as I said, growers are actually putting in some of their own money. The challenge there is, and it might be similar for you, some of our growers rent the land. And so they're not gonna invest in a system where next year someone's gonna come in and put in, Kaywood Estates, and before you know it, you've got 12 houses growing. So there's a bit of a challenge there for some of our growers. So what type of irrigation system, if I can ask, are you using now?
We're doing flood off of SRP.
Flood off of SRP?
Yeah.
So you've got the alfalfa valves that you open up, or?
We have some waterman valves, some distribution gates, some top
Okay.
gates, a lot of pumps. And
How many acres?
19 in total, but irrigated probably closer to about 12 or 15.
So you could, even using that, you could still come off of that and put it into a holding tank and put a drip system into something like
Yeah, and so we have a bunch of different farmers on our on the land. So some of them do pump to the tanks.
Do they?
Yeah. And then we kind of have a different version of almost like drip using the pressure coming off
Uh-huh.
off of the flood. It's more efficient, but probably somewhere like 20, maybe 20% more efficient.
Right, definitely. Also, the nice thing about sprinkler and drip is you can go and harvest just about any time. Right?
Yeah.
If it's flood, sometimes you just can't even get into the field.
Yeah.
You're stuck. You gotta wait. Also, with flood irrigation, at least on some of the stuff, alfalfa, some of the pasture grasses, what we found working with the folks in La Paz County that had center pivots that they were sprinkling irrigating alfalfa and then flood. What we found was not only did they save water, but the alfalfa came back faster. When you go through and you cut the alfalfa down, I mean, you're stressing the plant out, right? Like you're saying, and then you basically drown it with water, and it's still stressed out, and it takes a while for that plant to recuperate. Where if you have sprinkler, it usually comes back much quicker, and so the growth is quicker. Do you actually get more yield? No, probably not in the end. There's a better quality. We have to check for that, but you saved water, you didn't lose yield, and then our soil health person will tell you it's better not to flood irrigate and kill all the microbes and have them all sitting there underwater for 2 or 3 days. You want them to be active and to be working. So these new systems are actually help on many, many different levels for irrigation purposes. They're also a lot easier to apply fertilizers because you can apply directly with the drip irrigation system right to the plant. Sprinklers, usually you can find something, but you gotta be careful. Some of those can get pretty expensive when you're doing it. And so you gotta be a little bit careful with that.
Is there any type of research about if the different irrigation systems increase invertebrate pests? It seems like to me like a flooded field would be a better habitat than a less dry area.
I don't know that we've done any tests on that. Not that I know of. Doctor, I mean, you ever?
Test, I don't know if you're going to do that. Like, you were asking invertebrate, right?
Yeah.
Pests.
Mm-hmm.
The deal is, it's all about balance, right? Do you want, I mean,
Yeah, I was just wondering if the biomass of inverts was different versus different irrigation systems.
I think you should ask like Peter or someone. Or we have some, or I don't know.
The rule of thumb is there's a lot of clue that some of the insects would take from plants that's suffering from deficiencies in like irrigation, especially like for the plant that will like eat the sap or like suck the sap of the plant, like aphid, like whitefly and so on. And there's a lot of study that connect different irrigation deficit or even inefficiency with increasing population of these type of insects. So from there is like new trend now, especially with the increase adopting of new like techniques of irrigation like the subdrain and all of that to figure out whether they are good in terms of maintaining, not just like giving enough water because we will like have the comparison of irrigation water the same, but like irrigation like subdrain or like give you like a constant supply of water that the plant can take. Because with flood, you just like give them a lot of water at one time, and then by the end of the cycle, they are suffering. And that's the time when they will be target for some of these pests.
Gotcha.
So, and if this, period of suffering, like coincidence with a high population of insects, you will have an outbreak
Gotcha.
that you might not be able even to, control with your best method because it's just like an outbreak is hard to control. But if you have like more of, more constants and like all the time same level of water, like water availability for the plant, that's when the plant will not show any sign of suffering and they will not affect much of this insect, even if you have a peak of the population.
Gotcha. Thank you.
And plants that are healthier can withstand usually some pressure from pests, and so if you keep them healthy, as soon as they become unhealthy, the targets. I'm thinking of even bark beetle up north, right? I mean, as soon as we got into the drought, they just started taking over. But
There is also like many studies that giving evidence of some pheromone, which is like most of the pheromone of the plant coming out of this stressful plant that will attract insects compared to the healthy one. So even like when the plant is stressful, it's not enough, but they are inviting actually some of the evidence.
And also be careful. People talk about drip irrigation and how it increased my yield. I got more yield. They probably got more yield with drip irrigation because they got a better stand, right? Because they had a more efficient irrigation. Because they didn't have any place where it was under stress or over irrigated. So people talk about that and they say, I use less water and I have more yield. Well, you have more yield because basically you have better what we call uniformity. Every plant saw the right, the right amount of water. Every plant was healthy. Every plant germinated. You went from 80% to 90%, 95% germination, and so now you ended up getting more yield at the end of the season. But it's not necessarily because it used less water and all of that. It's because you actually have better uniformity, and that's how you actually get more of it. But in many cases, you don't necessarily get more yield. What you get is you get about the same yield, depending on what it is. Sometimes you get better quality because you're drip irrigating and you're applying the fertilizer. You can spread it out and it's going exactly where the plant needs. So for some of our vegetable crops, you get better quality with drip than you would with a surface irrigation system. Once again, a surface irrigation system is subjected to whatever the elevation of the field is. I had one grower talk to me and he was complaining we had a surface irrigation system. We had a part of the field in the back that just really didn't seem like it was doing very well, and we couldn't figure it out. And he said it's not growing very well back there. So we did a little elevation study out there, and it was 5 inches taller than the rest of this field. And if you look at it, it looks fine, and it gets wet. It's just not getting as wet as everything else. And so for him, it was like, well, why is that? And that's all it takes, right? Water does not run uphill. And it does not take much with the surface system. Water does run downhill. And you find those places right away when you're using it. Or you'll have a lake there really, really soon. So, any other questions? I'm curious. Are you growing stuff yourself right now, or?
Not currently, but I have an acre that I flood irrigate on. So I live in Salt River, so I have like a ditch, and then you can request water from the water department anytime. So it's free, being where I'm at,
Right.
where I'm from. So I think maybe I've been over irrigating, not quite knowing it. So because my plants have been struggling. I think what happens is like I'm probably getting the nutrients kind of washed out. I think that's what's going on.
What do you grow?
I have like seeds that are like our ancestral seeds. Like I still have seeds in my family since back then. So which is a variety of squash. I think it's like a shaw. We call it autumn hard. Oscar Mayer called Kuribasho. It's wrinkly and it translates to old man's wrinkly chest. So bugs like cassava.
Now you got me very on
Or we call it like Hawks, dog on old ladies, wrinkly knees. It's kind of a joke, but yeah, and I probably irrigate maybe like once every week and a half to 2 weeks. But yeah, I probably just got problems
You
with
might,
the soil.
yeah, so you might, what I usually tell folks is, there is a way you can go online and work it out, but, check to see how moist the soil is, and it would be better to irrigate 2 inches every, week than to irrigate 4 inches every other week, right? Because the plant will, once again, it will survive, but it will start to go into stress, it will be susceptible, and you'll actually get smaller squash and what have you. You might not notice the difference, but if you were to separate those irrigations a little bit more, some things will actually some plants will tell you that there's a problem. Um, Citrus trees are famous for this, and I had it even on my own one. My irrigation, I was irrigating every 2 weeks, and I noticed that my oranges were splitting. And so what happens is when the tree starts to go into stress, it starts grabbing all the moisture it can out of everything, and so it actually grabs moisture out of the fruit. And then when I put water on, it says, "Oh, I got water, good," and it grows really fast, and boom, it splits the rind. And so I wasn't irrigating often enough. And so what I did is I started irrigating once a week, but irrigating less. I actually got better quality fruit, and I didn't have as much. Tomatoes do the same thing too. Tomatoes will split like that.
Does that happen with watermelons as well?
Probably.
Yeah, I noticed that.
Probably watermelons will do that too. Once again, plants are very advantageous, and so when they have water, they'll use it up right away, and especially if they are under stress when they get it, and that's why even sometimes, if you look at once again, soil of the cactus, when there's water, you can actually see that, they store that water for a long time, but I would imagine if you drop back a little bit, that would be worth it. And then also, after you irrigate, go out there with that root bar or something. I usually get a 4-foot piece. On just about everything that you named, if you're going past 2 feet, you're putting on way too much water. And
Yeah. I noticed the difference too with plants in the front, closer to the ditch versus plants like further out.
Right. Right,
Yeah.
and those in the front are going to definitely get more water.
Yeah.
And those further out, definitely. We usually use about 2/3 or so down the run, we call it, as your target. But undoubtedly, once again, unless you have leveling equipment, which not all of us have, and you're not going to have, especially on smaller farms, you're not going to go out there with a laser level and do all this. So, you've got to play around with it a little bit and get to know your field very well, and then figure out what's the amount you can put on to make sure that it all sees it. I've seen places where we're irrigating alfalfa, and the water will just sit there because it's a low point in the field, and then especially this time of year, that alfalfa will just scald, and the next thing you know, you've got nothing growing there anymore because the water just sat there. But usually your irrigation on a field like you're talking about, the first quarter of that field will see a whole lot more water than the last quarter. And that's the problem with surface irrigation. You've got to put enough water on to get it all the way down. By the time you get all the way down there, you've over irrigated the ones in the front, and you're under irrigating those in the back. So you might be able to switch over and put something different in, or you might be able to split it up. The one that I had here. Let's see if I can go back to it. Oops. This has a gate on it, and so that also comes in a rubberized lay flat, and I call lay flat pipe, and you actually put little gates on that, and so what you can do is split your field in half. And so instead of having a 400 or 370 foot run, you only got a 150 foot run, and so that usually improves your efficiency in the surface system. Surface systems really lose a lot of efficiency on longer runs. For farm equipment, long runs are wonderful. As an engineer, I know that the most efficient field in the world is a field that just goes on forever, and you only have to drive your tractor one way, because every time you turn, you lose efficiency, right? But for irrigation purposes, the longer your run is, the less efficient you're going to be. So if you can cut that in half, you'll gain a lot. Even for some of the drip systems, you can do that too. If you're worried about pressure, split it in half and put some manifolds in there. Big challenge will be harvesting, things like that. You can put your your drip system under the ground, and you put it on top of the ground. Does it matter? No, it really doesn't matter. Does it matter which way it's facing? Yes, it does. So your drip system, you're using drip tape, the emitter should always face up. If you bury it, the emitter should face up. And the reason for that is if the emitter faces down and you turn the system off, if there's any type of debris in your water, it's going to settle to the bottom and it's going to settle into your emitters and it's going to plug them up. So always have emitters up whenever you're putting them in the surface. And when I put them on the surface, you can see it, so that's better. I can see if there's a problem. It's usually easier. Um, if it's a gopher through, sometimes you see the fountains out there, and so you can see it very easy. The problem is when you do, farming, when you're out there weeding, you hit the tape. When you're out there harvesting, someone's tripping over the tape. We've had people that have drip systems in. Workers who kind of started it all in Pinal County, they've had drip systems in for 20 years that were very drips and never had to replace them. They had to have a good regimen of putting acid in and all this other stuff, but it's, once you bury it down about 6 inches, keep it out of the sun, you keep maintenance up, you can have it for a long time. Once again, sometimes you have to have special equipment for that. If you have a smaller acreage, if you want to, you can pick up your tape and do some harvesting, do some tilling, and just pull the tape back out. Biggest problem I always had with surface tape is in the wind, really. That's the biggest problem. And you go out the next day and half your tape is in the acres. It's all still connected to the manifold. It's just all kind of laying over. It's like, so then I tried getting the staples out there. You got the. It's a hassle. It really is. But once again, depending on how much you're paying for the water and your point of view, saving water. I don't know any grower who doesn't want to save water. Most growers, it costs them a lot to irrigate. So most growers are looking for ways to save water. If they're not putting in higher efficiency systems, it's usually one of two reasons: either they don't have the money or they don't own the land. And so they're just renting the land, and so it's not worth them. I had one guy down in out in the West Valley, and I don't remember his name, but he was wondering if he should put in a drip system or a sprinkler system. And his son was trying to convince him. He's got I don't say he has a drip system. His son was trying to convince him to put in a center pivot, a sprinkler system, so because they're renting the land, and he said if nothing else, if they sell, at least we have we can take it with us. If I put in a drip system and it's buried, I got to pull it out, and once you pull it out, you can never use it again. And so he was debating what's best for what he was growing out there. And he said, we have drip systems that work great, so I'm telling my son, don't mess with success. But his son said, yeah, but what if they, and the way the West Valley is growing, I don't know about the rest of you, but when I head out I-10, I don't know where Phoenix ends. I mean, get out there, Buckeye, Litchfield, oh my gosh. Tonopah is now becoming part of the greater Phoenix area. It's just keeps growing out there. So there's a lot of alternatives. I'm more than happy to help you with looking at different things. Yes, sir?
One of the questions that we lately received is what about like irrigation water conditioning? Some like adding some ingredient to equal the pH or like alkalinity, and even like been introduced to some grower on a very small scale, but we are actually collaborating with some I think Australian company putting some filters. For me, it's like way too much. But what about like conditioning water? Would that have much impact?
I've worked with a few things in making water wetter, different things that you can do and put in, yeah. I haven't found anything to work really well. I mean, conditioning the water itself. So if you've got a drip system, and you want to lower the pH, because most of our soil is 7.8, at least 8, 8 plus, and that, which is high. And most of our vegetable crops like it, are, 7, 6. So the problem is that the soil is a huge sink, and people think, well, I'll just add some acid to it and I'll lower the pH. You could add gallons and gallons and gallons, and you're not going to lower the pH at all. But you've got a drip system, and it's buried, and what you can do is you can affect the pH around that drip system. And so sometimes that will make nutrients more available, etc. But don't think you're changing the pH of the field. It's not going to happen. And there's very few things. There was one guy who was looking at changing the ions and what have you of the soil. I've never seen any of them work, to be quite honest. And I don't think it's really necessary. pH is good if you're putting in acid for two things. Once it will reduce the pH around the drip tape, and also it will help keep them clear because you're actually adding acid to it. So that's fine. Also remember too, if you're using a drip system, you want to be irrigating more often. If you don't, plants are very good at, in the roots at least, at finding water. And what will happen is if you stress a plant in a drip system, the roots will grow into that, especially if it's a buried system, and they'll grow into the emitter, and it will plug them up in a second. So once again, with drip systems, you've got to be on top of it. You've got to have a plan B in case something goes wrong, because within a week you could lose an entire field if your pump goes out or something like that. So you've got to stay on top of things. You don't have a whole lot of reserve. So we usually irrigate more often with drip systems and keep the soil fairly wet year round, just because we can't recover very much from it. And also because of the salts too, right? So you have to, that's the other thing you got to be a little bit careful of. If you're surface irrigating, you're pushing the salts down, probably no problem. If you're sprinkler irrigating, you're pushing a little bit of the salts down, some of them will stay on, but if you're drip irrigating, wherever the edge of that drip water is, so if it was buried, wherever the water stops, that's where salt's going to accumulate. And so if it's buried 6 inches and the water's coming up to the surface, you're going to accumulate salts at the surface. And the first year you won't notice, and the second year you won't notice, and third year something will look a little off, and year 4 your germination goes down for some reason, and year 5 you do a soil test and you find out that you've got salt in the top inch of your soil that is just off the chart. So
do you suggest some kind of hybrid, like
system if you can, but those are so expensive to put in.
I mean, how if the salt builds up on the surface?
So what we've done is, if the salt builds up on the surface, what growers have done is actually gone in and they've altered their planting and actually put in a V and then put the seed in there, and then they'll cover it back up once they have emergence. Usually, for the most part, plants are susceptible early in the season to salts. So when they're germinating, when they're young. Once they grow to get to a certain size, they usually can grow out of it. So what we've had is growers actually go in and put a V in their beds, right above where the drip tape is, and plant there and leave that V. And this way that it will grow out of it. Once again, those folks that have 20 years worth. But certainly, without a doubt, the drought we're going through, it's a challenge. Because usually we'll get rain that will force it down, and we just haven't been getting that. And it's, we got it. It's been spotty here and there. You're getting a little bit of rain, but not a whole lot. And whatever you do, don't get mad when you see the rain falling and you see someone irrigated. You do a little education when someone says, "I can't believe that, girl. Look at that. It's pouring rain and they're irrigating." So that pouring rain is only getting about a quarter of an inch of water. We all know that. Yeah, the rain's beautiful and it's nice, but the amount of water that crop needs is so much more. So don't hesitate to do a little education yourself and inform some folks. Okay. Okay, any other questions or anything? Yeah, Dr. Singh.
How much of the, because back in Mississippi, we used to use surge valve for the long feeds. So it's like a valve for long feeds. It's just to ensure the uniformity of the water depth.
So surge irrigation?
Surge valve, yeah, surge irrigation, like he was mentioning,
Right.
he has a, different
Right.
table in the front.
So that, yeah, so what that is you irrigate and you cut it off and then wait and then you irrigate again. And you kind of push the water through.
Yeah, we had a surge valve kept in the center of the, like in the middle of the front end. So it basically swings. It's just irrigate half of the field for like few minutes, and then another half for a few minutes, so that we will have a little bit wetland in the front.
Right.
Then it actually helps to have a better flow of the water to the other end.
So in general, I mean, we could put those in, but in general, for the most part, we have enough high flows and our soils have enough clay in them, and it's not necessary. I mean, we do still run into problems with 1,200-foot runs, but most of you won't have 1,200-foot runs, and even our girls that do, well, it's one of those things that you're saying where 20, 30 years ago, no way. We have more than enough water. Nowadays, I don't know. Would it be worth it? It might actually be worth it. I mean, who would add phosphorus to alfalfa 30 years ago? No, we don't do that. We don't need to. So, I know you
That's
don't know
what happened in Mississippi. We had too much rain, but now everybody is like, do we need a soil moisture sensor?
Yes.
Along with surge valve, because there is a higher city cost.
Yeah. And you can do that too. You can put in soil moisture sensors yourselves or what have you. They get pretty expensive though. And so it's kind of hard. Be careful what you buy. And once again, you can contact me and let me know what you're thinking of buying. The stuff that usually works really good is really expensive. The stuff that doesn't work so good that you can buy for
80 kilometers might be a cheaper option, but
Yeah,
then it's
yeah.
reading is not. I mean, it's
Yeah.
not as
These days,
user
a
friendly.
lot of Wi-Fi related
Oh yeah, all
sensors are
kinds of
coming,
stuff.
and it's on app based.
Yeah.
And it will give you like a little bit idea,
Yeah.
which end is more wet.
Yeah.
So at least that will help you to irrigate that. And
Once again, though, nothing will replace you going out and take a shovel and checking it out and seeing what's out there.
I was going to ask you about that on the flow meters to build into the system,
Uh-huh.
like what you recommended of like a mid-range, because we've used, like our system has on the main line, like the H&a-half pipe.
Uh-huh.
We have one of those like hydro line that's connected to the controller, and
Right.
you can read that and see it. But for the actual, like for an individual plot or zone, the only thing we've ever tried are like those little RV,
Uh-huh.
but I just don't believe them because they're all so different. And
Yeah,
that's where the screw on is.
but I think they'll work well.
Yeah.
You're trying to get an idea.
Yeah.
Is it really, are you really getting 20 gallons per minute or is it 22 that's going through? And I don't know that would matter to you all that much. So I think that the technology's coming along. And if you've got the main one on, that's the one that you'd be looking at. And, we always did a thing where, to find out how much water we put on, we would always, measure before and measure after and see, and kind of get an idea. Well, normally when we irrigate, we use this many, gallons, and all of a sudden now we're using twice as much or 1.5 times. But now I know they're different ones. You got price and you got accuracy and repeatability. It is kind of a tough thing. I mean, once again, if you want to, you can buy the steel flow meters, and they're hundreds of dollars, and it's quite expensive. So, if you're just trying to get an idea, they're probably out there. Okay.